So I'm going to talk about the Great Barrier Reef as a case study, and you can see there was a blog I put on the Ian website that you can check back in April 2013 when I talked about the literacy. The literacy are these 7 principles. Largest reef complex in the world. GBR has got a massive catchment with runoff of freshwater, sediments, nutrients, and toxicants impacting the reef. Has regular large-scale disturbances. Climate change poses an immediate and real threat. The Great Barrier Reef supports a lot of human use, indigenous, recreation, commercial fishing, and tourism. Supports high biodiversity, including megafauna, and the marine park is managed as a large contiguous unit. So it's the largest coral reef complex in the world. It starts up in Torres Strait at about 10 degrees north at the northern tip of Cape York of Australia, down the Queensland coast, and all the way down to the Tropic of Capricorn here. And as you can see from the satellite view, there are these ribbon offshore reefs and these larger platform reefs inshore with extensive lagoons associated with them, and then there are fringing reefs in some locations along the coastline itself. So there's lots of different kinds of reefs, and they're all very unique and diverse across the spectrum of this large latitudinal gradient. Here's the catchment of the reef. It's fairly narrow to the north, and you can see lots of development in the wet tropics with sugarcane in particular, but also bananas and pineapple plantations. And then this gray area is grazing. So this is low density, very little urban development, except a couple little locations along the south and up here the red, but largely grazing cropland and low intensity agriculture. And as a result of the runoff of the reef, you can see that the plumes that extend into the inshore reef areas, and you can see this is the plumes from a maximum plumes during a very wet period, 2010, 2011. And you can see some of these offshore reefs are very infrequently impacted by even these large wet years with these plumes. So the inshore, but up here in the north, where the catchments are smaller and the reefs are closer, they are impacted by those plumes. And those plumes bring with them sort of a cocktail of freshwater, sediments, nutrients, and if there are toxicants around, the toxicants will join. So from this catchment, you can see aquaculture and grazing and farmlands with these rivers that are estuaries most of the time, but then turn into rivers during these pulsed events. And you see this thin layer of fresh water that pulses out, affecting these nearshore reefs and not affecting the offshore reefs. See this coastal wedge, they call it, where there's buildup of sediments and associated nutrients that are resuspended and cause turbidity, shading out the inshore seagrasses, dugongs, turtles, and fish populations in the inter-reef areas offshore. So one of the things that's happening is that the hard coral is diminishing. You can see this is before and after 2011 Cyclone Yazzie, and you can see how the reef is, the rubble here has been colonized by algae, green algae, following the destructive force of the cyclone. There's a slow but steady change in inshore reef structures. You can see in the Great Barrier Reef expedition that the British Museum led back in 1929, they mapped out this Mangrove Island, and this is a little island with a lighthouse called Low Isles. And you can see that this Mangrove Island has continued to expand. In a nearby reef, this is called Green Island. There's an aerial photo from 1936, and then a sequence. You can see that the seagrasses here are filling in behind this island, so that there's this transition with all this additional soft sediments and rich in nutrients. It's allowing these mangroves and seagrasses to thrive at the expense of some of these hard corals. It turns out that reef organisms are extremely sensitive to nutrient enrichment. So we did an experiment for 3 years on the reef with these micro atolls, these little ponded areas at low tide, and we had these robots that squirted nutrients in twice a day at each low tide. And the first year we did this, we didn't see any visible response. The only response that we were able to detect after a year of chronic fertilization was in coral reproduction. The fertilization rate, the settlement rate, and the fecundity of the corals was reduced. The rest of the organisms, we saw some very subtle changes in nitrogen fixation to denitrification ratio. The stomatopods, the mantis shrimp, were affected. The giant clams, Tridacna, we saw some absorption by some of the algae, and the coral polyp skeletal structure was changing. So as we added nutrients, particularly phosphorus, they grew less calcium, and so they became more frail and easier to break off. We didn't see any change in the grazing, calcification, bioerosion, or the other algae, or the one thing we didn't study effectively was the benthic microalgae. In retrospect, after we did some subsequent research, we probably missed a big part of that benthic microalgae here. When we really upped the nutrients after the year of no big response, we started seeing these kinds of things happening with additional nitrogen and phosphorus responses. Here's some of the disturbances that occur. Cyclones. The Yazzie was one of the largest recorded in 2011. You can see its track here, and the coral cover reduction, particularly to the left of the cyclone, because that's where the most sustained wind in a cyclone that's below the equator, Coriolis, causes it to strengthen on the left-hand side, and you can see this broad swath of destruction of the reef in these areas. You can see these historical hurricane tracks that impinge on the reef pretty regularly. Another big disturbance is the Crownofthorns sea star, and the Crownofthorns is this large, and it's up to half a meter wide, multiple arms, and they eat coral polyps, and they have a planktonic stage. And so the research that is going on to understand the proliferation of these blooms, like many invertebrates, they have sort of a boom bust cycle, and so some of these booms occur when there are great sets of these planktonic stages, and that's been related to nutrient enrichment. The bleaching that occurs in high temperature, and this is a bleached area of reef, occurs when the zooxanthellae, the symbiotic dinoflagellates within the coral polyp, are expelled at high temperatures when respiration is getting too high. And you can see this is a bleaching survey in 2002. There was particularly high bleaching in the southern reef and a couple areas in the northern. And at the time, that was the worst bleaching recorded. But no, the summer, austral summer of 2015/16, had the largest bleaching recorded any time, anywhere in the world. And interestingly, it was up in the northern part of the reef that's typically the most pristine and most tropical, and that's where the devastation was the most pronounced. And so this was an area of great concern, and we're still looking at the aftermath of that bleaching event. Another real threat is ocean acidification. So what happens with this calcification rate that's been recorded using coral cores? You can take a coring. You can drill out these large coral heads, individual heads with living coral on the very tip, and go back and do annual tree ring analysis, essentially. And you can see that the calcification rates were very high in the 19th century, stabilized in the 20th century, but now we're seeing this dip occurring in the last decade. And that has to do with this absorption of carbon dioxide by the upper ocean, conversion to carbonic acid, and reduction of the the amount of calcium that's able to be used in calcification. So it causes declining calcification rates. So the reef itself is a great, we sometimes joke the GBR stands for Great Bankable Revenue. It's a huge tourism, several $billion a year of tourism. Asian and North American, European tourists come to see the Great Barrier Reef, and a lot of commercial and recreational fishing as well. A lot of indigenous use historically and currently. They're large megafauna, and not many places in the world can you see intact large populations of dugongs feeding on the seagrasses, or various sea turtles like this green sea turtle, or large sharks and huge schools of fish. It's managed and since the 1970s as a large contiguous unit called the Great Barrier Reef Marine Park that extends beyond some of those reef waters. I mean, from the edge of the outer reef out in there's some atolls out in the ocean that have separate protection, and the zoning of the park is a multi-use zoning. So there are some areas that are no fishing, no take, large areas of no take, some areas of fishing and dredging for shrimp, and lots of shipping of materials in and out. So it's a multi-use. It's not a large. It's not like a national park where nothing occurs within those reef, but it's a multi-jurisdictional management strategy. It's managed by the Great Barrier Reef Marine Park Authority. It was also created at the same time as the park, and they really have embraced adaptive management. They talk about the Reef 2050 plan and looking at how they go about monitoring the various inputs and outputs of the implementation plan. They also put money associated with the 2050 plan, hundreds of millions of dollars of federal, about $200 million federal and $200 million state money to improve water quality issues. In terms of integration, they do a lot of reporting and monitoring to feed into management, and there are lots of committees and panels, and I'm on one currently on that brings scientists and managers together to talk about the threats and the changes needed to respond to those threats. The regular report cards, we set this up in 2010, I think, was our first one. And we've got for the inner reef, not the outer reef, but the inner reef that are affected by the runoff, and you have these reporting regions of with the different basins of Fitzroy, the Burdekin being the two largest, and the wet tropics and Cape York up here, and then overall, and the indicators that go in this report card include seagrass, inshore seagrasses, include water quality, turbidity and chlorophyll in particular, and a series of coral metrics, and they're monitored by, seagrasses by Citizen Science Seagrass Watch Group, the corals by the Australian Institute of Marine Science surveys, and the water quality using mostly satellite and ground truth data. And you can see these targets that they've set associated with this 2050 plan, and the individual targets of pesticides, nitrogen, and sediments, and their progress, tracking their progress towards meeting those targets. And the report card's basically tracking that progress. In terms of resilience, there's a lot of interest in managing for resilience, and we've looked at various, the Great Barrier Reef Foundation, NGO, foundation that supports NGOs and research, has been looking at ways to measure this resilience and try to come up with ways to manage in terms of resilience rather than status. And that's a real transition in the management context. Two references, I think, that are worth looking at the original report card to the 2009 baseline report card. It's available on Ian Press. In the most recent Outlook report, the 2014 report, does a good job of summarizing status and Trends in the Great Barrier Reef. They're both richly illustrated. The report card's only a few pages long. The book is like 100 pages.